This is 3.5, factoring by grouping. Your essential question, how do you factor by grouping? So we're adding in a new type of factoring, which we've seen a little bit, kind of, but we're going to talk about it, okay? The distributive property can be used to factor some polynomials with 4 terms. When a polynomial has 4 terms, you can make 2 groups and factor out the GCF from each group. We call this method factor by grouping. So notice this is for 4 terms now. So the first few are just kind of an introduction to it. So we've actually kind of already done this. This is going to have GCFs that are binomials. So we're going to take out common factors, create groups. And so when I take out my GCF that is a binomial, I'll take out an x minus 2. So it's from each one. So x minus 2 is in parentheses in front, just like if it was a normal GCF, but now I put parentheses because it's a binomial. And then times with parentheses x plus 3. And there we have it. So like the next one, it's not quite right. So if it doesn't quite work out, we have an extra step. So in this one, I want the x cubed, it has to match perfectly. These do not match perfectly, right? They need to match perfectly. So I need x cubed to be positive and 2 to be negative. That means I need to factor out a negative 1 GCF. Negative times a negative is a positive. Okay, x cubed minus 2. If I factor out a negative GCF, it flips their signs. So the 2 is now negative and the x cubed is now positive. Now they match. So I can take out an x cubed plus 2 or minus 2 from each one, and I'm left with 4x plus 1. One thing to remember is you should always have at least 1 left. Okay, I write it here because a lot of people forget that there is a 1 in front. There's always at least 1 left. It never goes to 0. Okay, and then sometimes it's just as simple as reordering. Okay, I don't need to change the signs. I'm not going to factor out a negative because both the 2 and the x are positive. But we like it to be exactly the same. So in this case, I just reorder them. They stay the same. I'm not factoring out anything. I'm just reordering, right? 2 plus 3 is the same as 3 plus 2. We can reorder with addition. So I have an x plus 2 as my factor, and then a 5 minus x left. Parentheses, parentheses, done. Okay, this isn't completely factored by grouping. They already did part of it for us. So we want to go through the whole thing now. Okay, so we're going to group. Usually you just group the first 2 and the last 2 terms. Until we get to the end, that's when we have a multiply. So notice it's still going to be adding. So I'm going to look at this first group. What do these have in common? So 2b squared, right? They have a 2b squared in common. So I'm left with 3b plus 4. Plus, not multiply, plus this other side. What do they have in common? Well, they only have a 3. And I'm left with a 3b plus 4 if I factor that out from that group. Okay, and notice they match. If they do not match, you cannot factor by grouping. Don't just start taking things out and just assuming it's going to work. It has to match. If it doesn't match, it doesn't work. And grouping is not what you can do. So 3b plus 4 and 2b squared plus 3 left. And we're done. A lot of times you will have to end up factoring more, so be careful about that. And like with every type of factoring, we always check GCF first. So with all 4 terms, do they have something in common? Oh, they do this time. Why? So don't forget that. Always check for a GCF first. Now we group just the inside. Okay. So the y stays in front. So I end up with this group. I have a 5y squared in common. So I'm left with y minus 3. This thing doesn't look like it has anything in common. Okay, but if you don't even take something out, put it in parentheses still. Just makes it easier to see. Oh, look, y minus 3 is in common. So y in front, then y minus 3, the thing I'm taking out, then 5y squared plus 1. Don't forget, you always have at least 1 left. Done. Okay. Hopefully you're getting the hang of it. So we check for a GCF first. Nope, nothing in common between all four. So we group, and we group. So this one has 2x squared in common, this first group, so I have x minus 6. This group has a 3 in common, but notice, if I take out just a 3, it's going to have the wrong symbol, right? I want x, positive x. This is going to be negative x. So I know I'm going to try negative 3, and that's going to flip them. So x minus 6, the x becomes positive, the 6 becomes negative because I took out a negative GCF. So I end up with x minus 6, 2x squared minus 3. And there we have it. Okay. So obviously we're going to use that with all the things we've been doing. So factor and sketch the polynomial function. Label x and y-intercepts. Alright, so this whole thing, I'm going to start off with, do they have something in common? They do. F of x, don't forget, is y. Same thing, but oh, don't want that. That's confusing. There we go. Alright, so they have a 2 in common, so I actually have to take out a 2 first. Next, we group. First group, second group. So from the first group, remember the 2 is still in front. First group is an x squared, that's it, so x minus 5. The second group, it's not quite right, so I'm going to take out a negative 1 because I want the 5 to be negative and the x to be positive. So that'll switch the signs. Okay, then we have an x minus 5 in common. And we still need to factor more, difference of squares. Watch for difference of squares, especially here. There we have it, factored completely. Lots of factoring. So we had GCF, then we had grouping, then we had difference of squares. 3 factorings to do. We also need, like always, degree, E coefficient, and in behavior. Always have to do that whenever we graph. So I'm going to look at the original. Leading term, highest exponent right there, so degree is 3, positive 2 lead, odd, positive, down, up. Then we need our x-intercepts. So set y equal to 0. Remember, f of x is the same as y. Okay. Usually you set that equal to 0, but it's because there's no x. When does 2 equal 0? Never. So it's not going to end up with an x-intercept from that. If there was an x in front, that is an x-intercept. We saw that a lot in the last objective, so make sure you don't just forget about that. So I have 5, 0 with a multiplicity of 1, negative 1, 0 with a multiplicity of 1, and positive 1, 0 with a multiplicity of 1. And finally the y-intercepts, or y-intercept, should only ever be 1. So this time I set x equal to 0. So I get 2 times negative 5 times positive 1 times negative 1. A negative times a negative makes a positive. There's no other negative, so this does end up positive. 2 times 5 times 1 is 10. So 0, 10 is my y-intercept. Okay, so I got to plot it. So negative 1, 0, positive 1, 0, and 2, 3, 4, 5, 0. And pass through both, start low, end high, and somewhere up here is my y-intercept of 0, positive 10. Got to pass through every point, not bouncing on any of them. Well, I'm going to move this thing because it doesn't quite line up. There we go. There we go. And we have our sketch. Done. Okay, example 5. Same thing again. Check. Do we have a GCF? Yes, we actually do have a GCF. Again, it's a 3. Okay, now I group. Whenever there's 4 terms, the only type of factoring we know so far with 4 terms is grouping, so we're going to group. As you can probably expect, your homework has a lot of grouping. So the second one, that's -9, notice I'm taking out a negative, so they both turn positive, positive x, positive 3, which then matches. So I have a 3 in front, x plus 3 in front, and then an x squared minus 9. Oh, and I have difference of squares again. That's going to happen a lot. And notice I have 2x plus 3s, so to get this correct, I got to combine those. So x plus 3 squared, x minus 3. So now we're going to have something with a multiplicity of 2. Okay, so we get our degree, which, look at the original problem, the leading term is 3 again. It's coincidence, don't think it's always 3. Positive 3 for my lead coefficient, and my end behavior happens to be the same, down, up. We've seen all sorts of them. I think every problem in this notes ends up being down, up, but you should have experience with all sorts of things. So X-intercepts, plug in y equals 0. Okay, hopefully you're getting to the point where you could easily see there's no x here, so that's not going to give me anything. It has to have an x to give me something. If it has an x, pay attention to it. This one will give me x equals -3, so I get -3, 0 with a multiplicity of 2. This one's going to give me x equals +3, +3, 0 with a multiplicity of 1. And finally, we need our y-intercept. Set x equal to 0. So y equals 3 times 0 plus 3 squared times 0 minus 3. Okay, so I get 3 times 3 squared, which is 9, times -3. So there's only one negative, so it will end up being negative. So 3 times 9 times 3 is, or times -3 is -81. So 0, -81 is my answer. Okay, make sure when you have your work, you pay attention to bounces versus pass-throughs, and you pay attention to the correct end behavior. So starts low, down, cross, 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 ends high. And I bounced on the -3, passed through on the +3, and I hit my y-intercept without any extra crossing of the x-axis. Okay, example 6. Sometimes they make you make the formula f minus g. Remember, the thing you subtract changes all the sign. We're subtracting everything, so it's -4x plus 12. This one doesn't have a GCF, so I just group. See my common term. It's difference of squares. There we have it. Degree, lead coefficient, and end behavior. Look at the original right here. Leading term, degree is 3, lead coefficient +1. Once again, happens to be down, up. It's not always going to be that. X-intercept, 0 equals x minus 3, x plus 2, x minus 2. So I get x equals +3, x equals -2, x equals +2, all with a multiplicity of 1. Y-intercept, plug in 0 for x, two negatives make a positive, so I end up with 3 times 2 is 6, times 2 is 12, so 0, 12 is my y-intercept. Okay, so we got to plot all those things. So +3, 0, negative 2, 0, positive 2, 0, and 0, positive 12. Down, up. So I should be able to pass through every point without any extra passes of the x-intercept with down, up as my end behavior. And there we go. So that's factor by grouping, and then graphing with factor by grouping. So make sure you have your essential question, answer, and you write your 3-sentence summary.